today's lecture, we will discuss some basic concepts in chemistry. So let's start. As we already know in our previous lectures that chemistry is a branch of science in which we study the matter. So the matter is composed of an atom, which is a fundamental piece of matter that can take part in any chemical reaction, having same properties as its respective element. Now, the atom is made up of three tiny kinds of particles, which are called subatomic particles, namely proton, neutrons, and electrons. The protons and the neutrons make up the center of the atom, which is called the nucleus, and the electrons flying around above the nucleus in a small cloud. Their pathways are known as shells. The first time this word was used by an ancient Greek philosopher, Lysippus, from atoma, which means indivisible. John Dental proposed a theory that each chemical element is composed of atoms of a single unique type, and though they cannot be altered or destroyed by the chemical means, they can combine to form more complex structures or chemical compounds. This marked the first truly scientific theory of the atom, known as the atomic theory, or it is also known as Dalton atomic theory. Now, what was the background of this theory? So, near the end of the 18th century, two laws about chemical reactions emerged without referring to the notion of an atomic theory. The first law was the law of conservation of mass, which was formulated by Antoine Lavoisier in 1789, which states that the total mass in a chemical reaction remains constant. The second was the law of definite proportions, first proven by the French chemist Joseph-Louis Proust in 1799. This law states that if a compound is broken down into its constituent elements, then the masses of the constituents will always have the same proportions regardless of the quantity or source of the original substance. Another term which is frequently used in chemistry is molecule. What is a molecule? So, molecule is a group of atoms which are bonded together, representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. For example, a water molecule. Then another term is called ion. An ion is defined as an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. There are two types of ions: cations with a positive charge due to the loss of electron, and anion is a negative charge by gaining electron. A compound is a substance formed when two or more chemical elements are chemically bonded together. For example, water. In water, two hydrogen atoms bonded to an oxygen atom. It lies in the category of compound because of chemical reaction in between its components. Now, if we look at the anions, they are larger in size than the corresponding neutral atom. Why? Since by adding electrons, it increases the number of electron-electron repulsion interactions that takes place. And the cations are smaller than the corresponding neutral atoms, since the electrons, which are furthest away from the nucleus, are lost. So, an ion will have larger size than the corresponding neutral atom, and the cations will have smaller size than their corresponding atoms. Now, there are some molecules in which both the positive and negative charges are present at different locations. Such types of ions are known as zwitter ion. So a zeta ion can be defined as a neutral molecule with positive and negative charges at different locations within that molecule. For example, an amino acid contains both acidic and basic centers. The isomer on the right is a zwitterine, in which you can see a positive charge on the amine fragment and the negative charge on the carboxylic acid fragment. Now we will discuss what is mixture and how many types of mixtures are there. First, we'll define a mixture. A mixture is made from different substances that are not chemically joined. For example, powdered iron and powdered sulfur mixed together makes a mixture of iron and sulfur. A heterogeneous mixture is simply any mixture that is not uniform in composition. Using various means, the parts in the mixture can be separated from one another. Pizza is a heterogeneous mixture of duck, sauce, cheese, and other toppings. Homogeneous mixture is a solid, liquid, or gaseous mixture that has the same proportions of its components throughout a given sample. Water is an example. It often contains dissolved minerals and gases, but these are dissolved throughout the water. Tap water and rainwater are both homogeneous. Now there are some differences between mixture and compound. A mixture is an impure matter and it is formed by the physical combination of mixing up of the substances, while the compound is a pure matter and is formed by the chemical combination of atoms of the elements. In mixture, the constituents they combine in any ratio, while in compound the constituents combine in fixed ratio. In mixture, the constituent retain their properties, while in compound the constituents don't retain their properties because a new substance has been formed. In mixture, the components of the mixture can be separated by physical methods, while in compound the constituents cannot be separated by physical processes. Mixture is made of two or more components and does not have any chemical formula, while the compound is represented by its chemical formula. Compound has homogeneous composition, while the mixture may be homogeneous or heterogeneous in composition. The compound has sharp and fixed melting points, while the mixture does not have sharp and fixed melting point. The example of mixtures are pizza or iron and sulfur powder mixed with one another. While the example of the example of compound is water. Atomic number and atomic mass. Atomic number is defined as the number of protons in the nucleus of an atom is called atomic number, while atomic mass is the mass of an atom which contains protons plus neutron, and its unit is the unified atomic mass unit, where one unified atomic mass unit is defined as the 1/10 of the mass of a single carbon-12 atom at rest. So, as you can see in the first diagram, the X is an atomic symbol which is represented by, accompanied by A and Z in the subscript Z and superscript A. A is a mass number and Z represents atomic number. For example, in the next diagram, you can see helium. The symbol of helium is He. Its mass number is 4 and atomic number 2. Now we'll discuss what is mole. So, mole is a unit that is used to quantitatively measure the amount of a substance. So, it is a counting unit in chemistry. 1 mole of any substance contains 6.022 into 10 raised to the power 23 particles. The particles could be atoms, ions, or molecules. It is defined as the number equal to the number of carbon atoms in exactly 12 grams of pure carbon 12. It has the value of 6.022 into 10 raised to the power 23, and this number is called our quantum number. So 1 mole of anything consists of 6.022 into 10 raised to the power 23 units of that substance. Just like a dozen eggs is 12 eggs, a mole of eggs is 6.022 into 10 raised to the power 23 eggs. Molar volume is the volume occupied by 1 mole of an ideal gas at standard temperature and pressure. Its value is 22.414 liter per mole. Now 1 mole of any gas will have the same value for this. 1 mole of oxygen and hydrogen having different masses have the same molar volume at standard temperature and pressure. Molar mass is a physical property which is defined as the mass of a given substance. Substance may be an element or a chemical compound divided by the amount of a substance. Its basic unit is kilogram per mole. The molecular mass or molecular weight is the mass of a molecule. While formula mass is the sum of atomic masses of all the atoms in a formula, regardless of whether or not the compound is molecular. Its unit is kilogram per mole. The key difference between formula mass and the molar mass is that the formula mass of a molecule or a compound is the sum of the atomic weights of the atoms in its empirical formula, while molar mass is the mass in grams of 1 mole of a substance. Now we will define what is molecular formula and what is empirical formula. Molecular formula is a chemical formula that shows the total number and kinds of atoms in a molecule but not their structural arrangement. For example, the molecular formula of ascorbic acid is C6H8O6. Now, empirical formula, it shows the actual number of atoms which are present in a compound. So, also the example of molecular formula is benzene, which is C6H6. So, it shows the actual number of atoms of different elements present in one molecule of that compound. There are some steps which are used for determining the empirical formula, for determining the molecular formula. The first step is to calculate the empirical formula mass. Second step is divide the gram molecular mass by the empirical formula mass. Multiply each of the subscripts within the empirical formula by the number calculated in step 2. Now we'll study what is empirical formula. Empirical formula of a chemical compound shows the simplest formula, which shows the smallest whole number ratio of the atoms of the different elements present in a compound, but not the actual number or arrangement of atoms. Formula for ascorbic acid is C3H4O3. There are also some steps for determining an empirical formula. The first step is start with the number of grams of each element given in the problem. Convert the mass of each element to moles using the molar mass from the periodic table. Divide each mole value by the smallest number of moles calculated. Round to the nearest whole number. Now the question arises, can compound has the same molecular and empirical formula? So the answer is yes, there are some compounds which have same molecular and empirical formula. For example, H2O, also ethanol. The chemical formula of ethanol is C2H6O. Now the reason behind this is the number of oxygen, because it is 1. As you can see in the formula of ethanol, there is 1 oxygen atom and it cannot be simplified further. So in this case, this compound has the simplest ratio between constituents, that is 1 integer. To find molecular formula when the other one is given, here's an example. The question is, what is the molecular formula of a compound that has a gram molecular mass of 34 gram per mole and the empirical formula HO? The answer to this question, how we'll solve this question, how we'll approach this question is that we will do this by using the steps which we discussed earlier. The first step was to calculate the empirical formula mass. We can do this by finding the mass of HO, means hydrogen atom and oxygen atom, by looking at the periodic table. So one hydrogen atom has a mass of 1.01 gram per mole. So the mass of one hydrogen atom is 1.01 gram per mole. Oxygen atomic mass is 16 and there is one oxygen atom, so 16.0 gram per mole is the atomic mass of oxygen. By adding these two, mean the atomic mass of hydrogen and oxygen, the answer is 17.01 gram per mole. This is the empirical formula mass. Now divide the gram molecular mass by the empirical formula mass. Dividing the gram molecular mass by this value yields the following. As you can see, 34 divided by 17, the answer is 2. Now multiply each of the subscripts within the empirical formula by the number calculated in step 2. Multiplying the subscripts within the empirical formula by this number gives you the molecular formula H2O2. This formula corresponds to the compound hydrogen peroxide.